functions. A rational function is f of x is the quotient of two polynomial functions, a of x and b of x, where b is non-zero. Okay, so a is a polynomial function and b is a polynomial function, and b cannot be zero. The domain is the set of all real numbers, excluding the values for which b of x equals zero. We dealt with this before. Okay, we cannot have zero in the denominator, so the domain is everything but the number that's going to make the denominator zero. Alright, move forward. Here we go. So the reciprocal function is the most simplest rational function that we know, that we dealt with, okay? Should look familiar. It's that same set of 1, that is a polynomial function, it's actually a monomial, and x is another polynomial, more specifically a monomial function, okay? So it's in that same setup. Now each rational function has asymptotes. Again, those are lines that the graph approaches, doesn't cross, touch. However, certain rational functions, none that you'll get to in pre-calc, you might get to it in calculus, calc 2, calc 3, depending on how far you go, you will run into rational functions that actually do end up crossing at that asymptote, okay? But I'll save that for that teacher. There are 3 types. Vertical, which we've talked about plenty of times. Horizontal, we'll dive a little bit more into, which you did last year. And slant/oblique. Okay, depending on which textbook and which version you're looking at, some textbooks call it a slant asymptote, some will call them oblique. So, it's one or the other. Are we good? So, vertical asymptotes occur at the real zeros of b of x. So in other words, you said b of x equals 0 and solve. What is b of x? That's the denominator. Remember that general form that I gave you guys, a of x over b of x? B of x is the denominator. So we're going to find the vertical asymptotes of n of x equals x over x squared plus x minus 2. So, how do I do that? How do I figure out what those asymptotes are? Some of y'all check the slant. You know what that means, right? Sit up straight. Drop some arms. Stay engaged. Here we go. So, how do I find the vertical asymptotes? What do I do?
Set the denominator equal to 0 and then solve.
And how do I solve this?
Factor it.
You have to factor it. Very good. If it is factorable, sometimes it might not be factorable. Are there 2 numbers that multiply to give you a negative 2 that add to give you a 1? You said negative 2 and 1? 2 and negative 1. So then we said both of those factors equal to 0. And my vertical asymptotes, which are actually, I have 2 of them, are at. Now it's very important, especially since you guys are, heading into IB. These are equations. All asymptotes are equations, and so you want to make sure that you actually have the x equals part along with it. Okay? Because if you don't, you are penalized for it. Okay? So remember, x equals that number. Cool? So again, remember the domain of a rational function is all real numbers except where the denominator is 0. So what would be the domain of this function? N.
Negative infinity to negative 2. Union. Negative 2 to 1. Union 1.
Very good. That would be your domain for this rational function. It's everything but those vertical asymptotes. Does everybody understand that? This is interval. Anybody want to write it in set for me? Because you can't do that, Trevor. You can do it both ways. Either way. Okay?
Is it negative 1 or 1?
It's a negative, I think. Yeah, people are together.
I think it's supposed to be positive.
Oh, it is something positive? Oh. Never mind, this should be a positive. Questions?
Can you pick that up for just a
Yes. Asymptotes. You look at the degree of A of X and B of X. You got to look at the degree. Okay, all of the functions we dealt with so far that have been rational, they've always been at 0. Okay, but now we're going to be dealing with ones that aren't 0. So you got to look at the degree. If the degree of the numerator is bigger than the degree of the denominator, smaller than the degree of the denominator, y equals 0. That is your horizontal asymptote. It is going to be 0. However, if your numerator is equal to your denominator, the horizontal asymptote is y equals c. C being the ratio of the leading coefficients of the numerator and the denominator. Lastly, if the numerator is greater than the denominator, there is no horizontal asymptote, but a slant or oblique asymptote.
So, if the numerator is less than the denominator, so the top less than the bottom, then you have an asymptote at 0,
Y equals 0.
at y equals 0. And if the numerator equals the denominator, so it's like 3 and 3, it's the ratio. What do you mean by the ratio?
So if ratio means the fraction between the leading coefficients. So say you had y equals 3x plus 1 over x minus 2. The degrees are the same, right? So then you will look at the leading coefficients, which are 3 over, which is just 3. So your horizontal asymptote would be y equals 3. So ratio, fraction between your leading coefficients. Yes, surely can, surely can.
I mean, I thought I was the only one confused, but I didn't want to.
So basically, when you're given a rational function, okay? Remember, a rational function is a polynomial over another polynomial, like we have here, okay? To figure out what the horizontal asymptote is going to be, so basically that horizontal line that the graph is going to get really close to but not cross and touch, then we have to look at the degree of the numerator and the denominator. Let's look at a different example. Let's look at the last one, okay? What's the degree of the numerator here?
1.
It's 1. It was not technically there, but we really don't have to write 1 when we don't have to, right? What's the degree here?
2.
2. So because the numerator is smaller than the denominator, when we graph it, you're going to see that the ends are going to get really, really close to the horizontal asymptote, which is y equals 0. And, of course, my calculator isn't up. If I were to graph this, you would see that. You would see the curve getting really, really close to 0, but never crossing or touching.
So, are you able to have a vertical, in one equation, like x over, where's that example?
It's the one right before x.
Oh yeah, x over x squared plus x minus 2. Could that be an example of a horizontal and vertical asymptote at the same time?
Yes, you can have both vertical and horizontal in one. But what you can't have is you can't have a horizontal and a slant at the same time. It's either or.
What about a vertical and a slant?
Yes.
Okay. So, my question is that you identified vertical using the bottom?
Correct.
Okay, and the horizontal using using numerator versus denominator, or
Correct.
Okay.
Okay. So as you see here, this is what this function would look like. Okay? You have a vertical asymptote at -2. You have a vertical asymptote at 1. Would you guys agree? The curves are getting really close to it. Look at the horizontal. On the ends, it is approaching, getting very, very close to 0. Does everybody see that? It's one of those situations. I'm going to have to worry about graphing one like this. Okay? Let's look at the other one. The last one that we just did was 3x over x minus 2. Where would the vertical asymptote be?
Me too.
At +2, and we saw that the horizontal should be at 3. So when we graph this,
How did you figure that out?
when we looked at the degrees of the numerator and denominator.
Okay.
see there's the vertical asymptote at 2. And you see that it's going to be getting really, really close to positive 3. If you can't see, you can always look at where? You can always look at your table and see as x gets really, really big, what number is it getting close to? It's going to be getting close to that horizontal asymptote of 3. Questions?
Yes. Can you go back? Okay. So that whatever equation you were saying, what over x minus 2, what was that?
This one? This one?
Yeah. Okay. And you said it would be 2. If there would be a horizontal or vertical asymptote at 2.
Vertical. Because you set the denominator equal to 0.
Okay. Thank you. So for vertical, you set the denominator equal to 0.
Correct.
And you solve.
Right.
And since that's just already in, you don't need to factor it. It would be 2.
Right.
And for horizontal, all you have to do is memorize these ones.
Yeah.
Okay. Thank you.
So you're gonna be looking to your sheet.
Mine's just a.
Okay. Yeah, go ahead.
So you're gonna be looking for
Eight.
both in an equation? Like
Yes.
for that one?
You're going to be looking for both. It's not one or the other. It is both. You're looking for a vertical asymptote and a horizontal or slant asymptote. Okay? Now, your slant asymptotes, these occur when your numerator is bigger than your denominator. To find what the slant asymptote is, you have to use synthetic division.
Synthetic's the one where you make the box and plug it in.
Exactly. Okay? And then whatever you get as the result of doing synthetic division, that is your slant asymptote. So what we're about to do is we're about to look at 3
So
examples.
you use synthetic on the bottom or the top?
You do it with both of them. You'll see in a second.
Oh, okay.
Let's look at examples. Let's look at some examples here, okay? We're going to find just the horizontal asymptotes of these 3 functions. Okay? And yes, you do have to write the functions in.
Nice touch.
Yes,
And y'all be like, where's the function?
No, I think I figured it.
And I'm like, this is it's like, nice.
I'm guessing it's so nobody can work ahead.
I
Yep,
like
please.
that. So wait, if you have an x
Real
on the
quick.
bottom,
Change it to a -3.
Oh, man.
if you have an x on the bottom, how can you tell if the numerator is greater than the denominator?
Like in example A?
Yeah.
Okay. Well, if there is no x in the numerator, that clearly had to mean that if there was an x there, what would be the degree?
To the 0.
Because anything to the 0 power is what?
Nothing.
It's just 1.
One.
So it's not even there, right? So when there's no x, that's basically a degree of 0. And in this case, is the numerator bigger or is it smaller? Smaller. And when the numerator is less than the denominator,
Y equals 0.
and there is the horizontal asymptote. So you look at the degree.
So it's just y equals 0.
It's just y equals
You
0.
don't plug anything in,
Nope, don't plug anything in.
just y equals 0. So what does y equals 0 mean? Like it just adds 0?
That means that there's a horizontal asymptote at 0, which means that at the ends, the end behavior, as x approaches infinity, is going to be approaching 0. As x approaches negative infinity, it's going to be approaching 0.
So it's gonna be like that.
So it's going to... Christian.
I'm just confused for like A for that one. Couldn't what if I know x can be anything, but what if it were like 2? It wouldn't necessarily be the numerator wouldn't necessarily be bigger than the small.
Are you talking about if the numerator was 2?
If x was 2,
If
the numerator would be bigger. Like you can't really tell if there's an x. It's not necessarily.
But see, if the degree of the numerator was a 2, then there would be an x there. But since there is no x there, then that meant the only number it could have been is a 0.
No, I'm saying if x like itself was 2.
X squared.
No, x was
Like
2. 2 plus 3 equals 5. It's not necessarily like smaller.
If there is no x there, then that means the degree is 0. You're looking at the degree, you're not looking at the coefficients, you're looking at just the degree. What you're trying to tell me is that we have, when you're dealing with horizontal asymptotes, we're talking about the degree here, okay? For the second one, what's the degree of the numerator?
1.
It's a 1. What's the degree of the denominator? So we compare the degrees. The numerator is to the denominator, which means we look at what? The ratio between the coefficients. So it's 15 over 1, which is just
15.
So the horizontal asymptote is y equals
15.
So we look at the degree. Yes,
If it was 15 over 2, would your y equal
15 over 2. Exactly. If this was a 2 instead, it would be 15 over 2.
What if there's
7.5.
if it's to like a certain power, does that affect anything? You're just looking at
They need to be equal. So if both of these
Yeah.
were to the third power,
it's gonna be 15.
it would still be 15 because they're still equal.
Okay. I just wanted to.
Yep. What about this one here? What's the degree of the numerator? 2. What's the degree of the denominator?
1.
So the numerator is,
So you have to do synthetic.
so there is no horizontal asymptote, there's actually what? A slant. To find out what that slant asymptote is, we do synthetic division. Okay? So this is pretty much division. It's x squared minus 7x plus 10 divided by x minus 3.
Oh.
That's what it is, right? It's a fraction. You're dividing. What's going to go in the backwards L? The 3, because this is what we're dividing by. And what's going to go beside it?
1.
6, 7, and 10.
And this is what we do synthetic division with. We bring down the 1. 3 times 1 is?
3.
We subtract, we get what? We multiply. Add, sorry. Negative 12,
Negative 2.
which is our remainder. So, we'll always get a remainder because if we got 0, that means there's something else going on in the problem that we're going to talk about later. So my slant asymptote is the equation x minus 4.
What about if you don't include the remainder?
Nope, you don't worry about the remainder.
What is the remainder affect?
And this is just such pretty much what's left over. It doesn't affect the slope of this, the slant, anything. Yes, ma'am.
If you were dividing by, like, say, to the third power, you would put, like, x squared.
If this was something other than a linear factor, you would have to use long division to divide it.
So you have to get down to x to the first power.
Nope, if it was anything higher than a linear function, on the top or the bottom, you still would do the normal synthetic rules. If it started out as quadratic, you go down to a linear. If it was a cubic, it would be a quadratic, and so on and so forth. Yes.
Let's say it was 2x minus 3 on bottom, still do synthetic.
And you would just have to figure out what the 0 is. And do that.
We learned it differently last year.
Probably a long bit. There you go. Well, you could do what? If it was 2x minus 3, you would just find the zeros. Ain't it pictures land. Sit up straight. No. It's this turns into this. Which means you're not focused, you're not paying attention. You too, sir.
He nods back. She points at him. He's like, yes.
Questions on horizontal asymptotes. You want another one?
Yes.
Okay, here we go. Here's another one. And actually, find the vertical and horizontal asymptotes this one. You guys got space. Yeah, put it off to the side, okay? You got space. Here's one.
Where's the space?
Off like to the side, unless you go like super big.
Okay.
You do right super big. It's okay.
We should.
You're finding vertical and horizontal asymptotes here. Here we go. Vertical asymptote, to find this, we do what?
You
What?
set it equal to 0.
What is it? You set the denominator equal to 0. So you'll have x equals 2, which is what you should have. It's not just 2, it's x equals 2. Okay? Now your horizontal, we have to look at the degree. The degree of the numerator is
2.
and the degree of the denominator is
1.
so the numerator is greater. So is there a horizontal asymptote?
No.
It's what?
Slant.
There's a slant asymptote.
So you use synthetic.
So what goes in the backwards L?
2.
And what goes here?
5.
Negative 10.
1.
2 times 5 is 10.
I started with the quadratic, and when I divided, I ended up with a,
5x equals y.
which is a linear function. So my slant asymptote is y equals 5x, which is a linear function that crosses the x-axis at 0 with a slope of 5.
I think I wasted too much time with questions.
You're fine.
So, will the x ever be to like,
A third power.
yeah,
Yes, but not for this class. It can be to a higher power, but not for this class, okay?
thank you.
Then you use long division, and then you actually have to graph a quadratic or something to. Real quick, the last little bit is review, because you guys should know by now how to find the x-intercepts and the y-intercepts of functions, correct? To find a y-intercept, we plug 0 in for x. And to find the x-intercept, we plug in 0 for y. Now think of it like this, right? If I plug in 0 for y, the first thing I'm going to do is get rid of my denominator, correct?
Yes.
And 0 times anything is what?
0.
So you're left with just the numerator equal to 0 every single time. So that's why it's just the numerator equal to 0 to find your x-intercept. Because that's what's going to happen every time. The denominator is going to go away.
The denominator's
Okay.
Go back up.
Yeah.
So here, what's the x-intercept?
Lynch.
Careful, gives me negative
2 over 2x plus 4x.
No.
x-intercept.
Oh.
What do? You set y equal to 0.
You.
Y.
So it'd be negative 2.
Okay. We're going to set y equal to 0. Okay. That's fine. We'll do this extra step. What do you do next to solve?
Multiply the denominator.
So when I multiply 0 by x squared plus 4x minus 3, what's going to happen?
It disappears.
So you have 0 equals 2, which is just the numerator equals 0, right?
Yeah.
Is that possible?
No.
No, 0.
There are no x-intercepts.
Wait, I thought that's a 1.
It's not possible.
That is possible. Because if there's no x-intercept, then what's happening at the x-axis?
There's a
That's a
hard
no.
There's an asymptote.
Oh, that's.
No.
Oh, look at you.
Okay. So you set y equal to 0. Because n of x, f of x, g of x, whatever variable of x is the y. When you multiply both sides by x squared plus 4x minus 3, doing that to get rid of this, but 0 times anything is just 0. This is the same thing as just setting the numerator equal to 0, and it works that way every time.
What
Yeah,
about y?
because 0 can't equal 2, that means this doesn't exist, which means there's no x-intercepts. It doesn't touch at all, which means more than likely there is a asymptote occurring. Let's confirm. Is the numerator less than the denominator? So that means it's a horizontal asymptote. That's why we don't have it. How would I find my y-intercept? So this becomes a 0. This is a 0. And so my y-intercept is over here to find my x-intercept. I just have to set
x to equal to x? What's that? 1! Oh.
You set your numerator equal to 0. There is your x-intercept. And you guys can find the y's just fine.